In this video, we're going to find volumes of other shapes where we know the formulas but we haven't derived the formulas. So determine the volume of each of the following solids, label any given information in the figure, include units in your final result, and round your answers to 2 decimal places. So we're given a basketball has a diameter of approximately 9.55 inches. Find the volume of the basketball. So a basketball is a sphere, okay, so basically ball shape is a sphere shape. That's what we call it in mathematics. And we're told the diameter, so this dashed line is representing the diameter, is 9.55 inches. So our volume formula for a sphere is 4/3 times pi times the radius cubed. Notice the only value we need to use this formula, 4/3 is a number, pi is a number, we just need the radius. So we were given the diameter, so we're going to start by finding the radius by dividing 9.55 by 2, and that would be 4.775 inches. Okay. Now notice it says to round our answers to 2 decimal places, but we're only going to do that at the very end. So you don't want to round along the way because then you're going to get more what we call round off error. So let's put this in the calculator. Okay. So first I want to put 4/3. Okay. I'm going to do this in one long string using parentheses. I'm going to put 4/3 in parentheses times, then we want to multiply by pi. I'm going to use the approximation of 3.14 times, and now I'm going to put the radius in parentheses and cube it. So 4.775, and the calculator has a cube button for that, or when you put this in your calculator you can use 4 divided by 3 times 3.14 times 4.775, and you can use the caret symbol and then the number 3 to raise something to the 3rd power. Now I will hit enter and I get, rounded to 2 decimal places, 455.81 equals 455.81, and our units are cubic inches. Let's look at our next shape. The Great Pyramid of Giza in Egypt has a square base with side lengths of approximately 755.9 feet and a height of approximately 480.6 feet. Find the volume of the pyramid. Okay, so here's a diagram of a pyramid. This is the square base, and it says its side lengths are 755.9 feet. Okay, remember, since it's a square base, all of its sides are 700, I don't know why I put division there, are 755.9 feet. So I'm just going to label 2 of them. Okay, and the height, which is indicated by the center of the base of the pyramid, and it goes straight up to the pointy part we call the apex, and I'm going to draw an arrow to it, and that is 480.6 feet tall. Okay. So our formula for the volume of a pyramid is going to be 1/3 times the area of the base, where the base is the part perpendicular to the height, times the height. Okay, so we're going to put in these values. So volume equals 1/3. Now we need the area of the base, and that's another reason I wrote these 2 sides of the square. It's not just going to be the one number, 755.9, because the area of the base is that value multiplied by itself. So 755.9 We could write squared. I'm just going to write 2 factors of it. And the height is 480.6. Okay. Now we're going to multiply this all out on the calculator. I wouldn't even enjoy doing this by hand. So let's start with 1 divided by 3 times 755.9 times 755.9 again, times the height, 480.6. And this gives us, okay, I'm never going to remember this number, 915,358, 915,358, 46.56, 46.56. And that would be measured in cubic feet. So I rounded to 2 decimal places there. And it's good practice to put in your commas because I can't even read this without commas. So 1, 2, 3, comma goes here. 1, 2, 3, comma goes here. So this is 91,535,846 and 56 hundredths cubic feet. And I'm just going to put this number up here and check it one more time because that was a mouthful. And it checks. Let's look at the last one. An ice cream cone has a diameter of 8 centimeters and a height of 13 centimeters. What is the volume of the ice cream cone? So here's our ice cream cone. It says the diameter is the circular part at the top of the cone. This is 8 centimeters. So I'm going to put this right in the center. Okay. And the height, which is the red part, which goes from the center of the base straight up to the apex, is 13 centimeters. Now our volume for the area of a cone, again this is similar to a cylinder. We're just going to basically take 1/3. If this was a cylinder, 3 of these would actually fit in a cylinder. So it's 1/3 of a cylinder, which is 1/3 times pi r squared h. So 1/3 times the area of the base times the height. So I'm going to put in these values. Oh, first, radius. We're not given the radius, we're given the diameter. So let's first find the radius. It's 8 centimeters divided by 2, which is 4 centimeters. So we have 1/3. I'm going to use an approximation for pi, 3.14, times the radius, which is 4, squared, times the height of 13. Now we're going to compute this on the calculator. We're going to put it in one big step. So 1 divided by 3 times 3.14 times, you could put in 4 times 4. You can use the squared button on your calculator. So I will do 4 times 4 times the height of 13. And our result is 217.7. Notice we're going to round up to 100th because we have 6 in the thousandths place. So 217.71. And that would be cubic centimeters.